Welcome everyone. This is going to be notes for solving absolute value inequalities now, okay? Um, okay, so we are going to be talking about this today. Absolute value inequalities are a little tricky because the graph actually looks completely different depending on if it's greater than or less than. So we're going to look at these two cases now. It is generally always going to be the same. So you can kind of just remember, okay, this graph goes with greater than, this graph goes with less than. But anyway, we're going to look at this. So we have the absolute value of x is greater than 7, okay? Now, if this was an equal sign, all right, we would know that the solutions would be 7 and negative 7. All right, so that's still where our dots are going to go. Our dots are going to go at 7. And our dots are going to go at negative 7. Okay? But now, where do our arrows go? Basically, is what we need to figure out. So it's the absolute value of x is greater than 7. So if you want to figure out where your arrow should go, look at one of your dots, all right, and think about which side of the dot does the number work, okay? If we plug in 6, okay, is the absolute value of 6 greater than 7? No, right? That's not true because 6 is not greater than 7. But if we plug in 8, right, the absolute value of 8 is greater than 7. So to the right of this dot works, right? Now, it's a little bit different down here, okay, because we're not just going to be going to the right, okay? Think about the absolute value of negative 6, right? Is that greater than 7? No, okay, right? Because the absolute value of 6 is 6. So 6 is not greater than 7. But if we plug in negative 8, the absolute value of negative 8 is 8, and 8 is greater than 7. So this dot actually will go to the left. So if you look at what we have here, right? We have one arrow going to the right, one going to the left. So this is a compound inequality, right? This is an or compound inequality. X could be greater than 7 or less than negative 7. Either of those numbers in absolute value will be greater than 7. So in interval notation, the way that we write this, all right, we're going off to infinity on the left, and then we're stopping at negative 7. Then we're picking back up again at positive 7 and then going off to infinity on the right. So a greater than or equal to sign is going to give us the or compound inequality. If it's less than or equal to, all right, like it is here, okay, again, we know the solutions are 4 and negative 4. Okay, but now where do our numbers go? So this time we want to be less than 4. So we want the value of the number to be less than 4, right? So 3 is less than 4, so we want to go this way. And then these are the numbers, when they're taking their absolute value, they're still less than 4. Like the absolute value of negative 2 is 2, which is less than 4. The absolute value of negative 6 is greater than 4, right? It's positive 6. So this time, this is going to actually be the and inequality. So this one is going to just be from negative 4 to 4. So if you have a less than sign, all right, it's going to be the and compound inequality where they come together. Greater than sign, they're going to be going opposite. So that's one thing that you have to keep in mind. So we're not going to be doing too many notes today, all right? We're going to isolate, just like before, create two cases, solve, and graph, okay? So the thing about the inequality, all right, when you create your two cases, so the first case, the positive case, is the easy one, all right? It's always just going to be whatever you see. However, when you do your negative case, all right, you actually have to flip the inequality sign, all right? We want to be less than negative 7. This is kind of for the same reason as above, right? The negative case flips and it goes the opposite direction as what the positive case did, just because you're taking those more negative values and turning them into higher positive values. So you split it up, your negative case, you flip the sign, and then you just solve like normal. So once you flip the sign, all right, you've created two problems that you can put on your graph. So we've got x is greater than 1, so that's an open dot at 1, greater than goes to the right. X is less than negative 13, that's an open dot going to the left for less than. So our interval notation, we have negative infinity to negative 13. And then we have 1 to infinity, all right? So not anything different than our regular solving inequalities was, just, again, turning a absolute value inequality into a compound inequality. So, for example, B, we've got 2x minus 3, that's going to be less than 19. When we make our second case, we've got 2x minus 3. This time we're going to flip it to greater than negative 19. And so we have to solve them separately. All right, so we've got 2x is less than 22. X is less than 11. Over here, we add 3 onto both sides. We've got 2x is greater than negative 16. Divide by 2, x is greater than negative 8. So these are both open dots again because there's no line underneath. So we're going to have a dot at negative 8 and a dot right here at 11. And then it's less than 11 and greater than negative 8. So less than 11 is to the left, greater than negative 8 is to the right. So anytime you see the lines coming towards each other like this, don't just draw arrows in, all right? That's wrong, okay? What you want to do is you want to connect the lines, all right? And so this is the and inequality, all right? This is the easy one to do interval notation. It's just negative 8 to 11, all right? So again, these ones aren't going to be much different than what we looked at yesterday, all right? Remember, you cannot distribute, okay? That's wrong. You have to cancel out that negative 4 because remember, we want to get our number by itself. So divide by negative 4, that gives us the absolute value of x plus 9. Now, remember our flip rule, okay? That hasn't gone. If you're dividing by a negative, we got to flip the sign. And that flipping the sign isn't the same as the flipping the sign that we're going to do later, okay? So this is now our new inequality. So our positive case is just going to be x plus 9 is greater than or equal to 5. When we flip it, our negative case, x plus 9 is less than or equal to negative 5. So you still have to flip it again over here, even though you flipped it already because you divided by the negative. So now we can get our solutions. We can subtract by 9, so we've got x is greater than or equal to negative 4. Subtract by 9, x is less than or equal to negative 14. So these ones are going to be going in opposite directions. So we've got a dot, solid dot at negative 4, solid dot at negative 14. We're greater than negative 4, so that's to the right. We're less than negative 14, so that's to the left. So we're going to need two inequalities here. The first one from negative infinity to negative 14. The second one from negative 4 to infinity. Last one, all right, that we're going to try. Okay, again, we just got this minus 9 here. So before we can split, we need to add 9 to both sides. So now we have the absolute value of 3x plus 6 is less than or equal to 33. So now we can split it up. So we've got 3x plus 6 is less than or equal to 33. And 3x plus 6 is greater than or equal to 33. So we solve. I know you guys know how to solve this by this point. All right, that's 27 divided by 3. X is less than or equal to 9. Do this. Ooh, I made a mistake. Hopefully you guys caught that mistake and you didn't just write it down. That should be negative 33. So minus 6 on both sides. 3x is greater than or equal to negative 39. Divide by 3. X is greater than or equal to negative 13, I think. So that can't even fit on here. Do we do something wrong? I don't think we did anything wrong, guys. I think that this graph is wrong. So if I did something wrong, message me and let me know. All right, let's do this. Negative 13. So we got a closed dot there. We've got a closed dot at 9. And we draw our lines in between. So we've got negative 13 to 9. So that's it. Okay, that's all we're doing today. You don't have to worry about the back page if you weren't in class. These 4 examples are the ones like on your practice. So you can give your practice a shot now. You can, if you're looking back at this, hopefully you've already done the practice. But if you have any questions, let me know and have a great day.